Okay, thought I'd go over a little bit more what I'm pretty sure is going on with this radio. As I said, it's a common thing that happens with these. This is a somewhat oversimplified drawing of one of the IF cans. Both in this radio are pretty much the same. You've got a plate, and the plate supply flows through this coil, across which is a capacitor. Of course, this is a resonant tank, 455 kilohertz. This is slug tuned. And the same thing over here, except this is the grid bias down here. Now I'm showing it as ground, but it's pretty close to ground. Normally this is connected from a stage further down the line to provide an automatic volume control. So there's a DC voltage on here that controls the gain of this stage, this being the grid of this stage, plate of this stage. So this whole thing, I mean, this has got a couple of 20 ohms or so. Same with this one. So pretty much across this whole area here is very close to ground. This whole area here is very close to B+, which in this radio at this point happens to be about 90 volts. It could be higher or a little lower than that, but nevertheless, the problem is this is a very high impedance circuit here. This grid, I'm showing it connect directly to ground. That's not the case. There's usually a few megohms between here and some other part of the circuit that has to do with the gain control of this. The point being that this is a very high impedance node, both sides of this, with regard to ground, actual ground. This side's pretty tightly bolted to B+. I mean, there will be a resistor somewhere between the power supply and this point. But the problem is these two capacitors. Both of these are inside this can, along with the coils. When you open the can up, it's obvious. You see two coils wound on a form, separate, apart, and it's pretty clear where the wires go. But in the cans that they used in these capacitors are not readily apparent. They're buried down into the base of the thing. And what happens is the dielectric for both of these capacitors is common to them, meaning it's a single piece of mica or whatever it is they use. I'll draw it in here. That. What often happens is a leakage path develops between this capacitor and this capacitor across this dielectric. It's not supposed that there should be no connection, no electrical connection between this side and this side, but for a number of reasons it will happen. That there will develop a leakage path. Got B+ on this capacitor, pretty much ground on this one, high impedance circuit. It does not take much leakage, electrical leakage, across this wafer of mica or whatever it is they're using to totally offset the bias for this stage, this tube. You know, his grid wants to be where it needs to be. It's all figured out and as it should be, and then suddenly you got this leakage path that's trying to put, well, could be 100 volts directly onto this grid. And when that happens, it's not going to work. So what you have to do, if that's what's going on, is to remove this, and by doing so remove both of these capacitors from the circuit, which means you have to then replace them with discrete components. You can solder them to the bottom side of the coil. You don't have to put them in the can. It's better if you do. Not get into why. It's a subtle difference, so don't worry about it. If you can get in there and get rid of this internal capacitor and tack on appropriately sized capacitors on the solder side or the under chassis side of those cans, go ahead and do it. It will work. It's going to work much better than if you've got this situation going on where there's this leakage across this dielectric. It's fairly common. I've run into it a few times, and boy, that can be a real head scratcher before someone wiser than you comes along and says, oh, you know. So I'm pretty sure what's going on with this. The symptom is classic. Now, I was thinking, just go ahead and remove, I suspect this particular coil, first one here, second one here. Because of the voltage measurements, I took DC appearing on the secondary of this. It should not be. I suspect that's what's going on with this coil. But I got to thinking, rather than just undo everything and pull it and open it up, it might be more educational to approach it from a bit of a different angle. Looking at this again, if I remove, assuming there's a leakage across that, and that's what's causing all this noise downstream and out of the speaker. If I remove this B plus and make the voltage across this part of the transformer, the IF can, make this basically ground. And therefore there would no longer be any leakage from this capacitor to this one through the common dielectric. If I remove this and that noise goes away, that's a clue. But maybe that is indeed what's going on. I'm pretty sure it is. I'd be surprised if it's not. As I said, I've already measured continuity through these. It's fine. It does tune in between times when whatever's going wrong is manifesting itself. Nothing but a bunch of crackly pops and stuff. Classic symptom of this. So what I'm going to do, and I'm still debating, do I want to start with this stage or do I want to start with this one? These are very similarly wired, typical of these radios. I see on this one B plus, this red wire is coming in right here. Plenty of slack, and that's just a bare wire. I can just cut that off, and if I cut that wire right there, that'll be removing B plus from this coil, this coil of this transformer. I really don't think it's this one, but it might be a better place to start. Plenty of slack here. Yeah, I think I'll start there. I'm going to cut that, see what happens. I'm going to do it live, save a bit of time. And depending on what happens when I cut that, if the noise goes away, I'll know that's where the problem is in here. I don't think it will. If it doesn't, then we'll cut. Let's see, there's all these red wires here, B+. See, going right to this filter cap. And there's a lead, plenty of extra slack in it, so I don't have to desolder that. I could just snip it off, and that'll remove B+ from this coil. And I'm almost sure if I do that, the noise is going to go away. Now, of course, you do that, you're not going to get any radio through it because you've disabled the stages, at least two, Pentagrid converter and IF amp. Down here, the AF amp and detector, diode, audio speaker driver, audio amp, and the rectifier. So the amount of noise this thing's making they're not radio, it should be fairly easy to tell which coil I really should look at and open up and get rid of this business. So let's carry on with that. Go hot, react down, power on, there you go. We'll go full Monty. Give it a moment. Now I have alligator clipped the speaker in so you'll be able to hear it. Okay. Yeah. It's interesting, right now it kind of sounds like a radio. But this problem, it will come and go. It will be intermittent. This chassis, I'm isolated so I can touch the chassis. The chassis really isn't directly connected to either side of the power supply. There are capacitors, two of them, for RF coupling of the chassis. It's interesting how they did that. Now, that right now sounds like a radio to me. It's tuned a little.
The award was excessive, but the court affirmed. So it's addressing down for Tyson, addressing up for the workers, addressing all around for the lawyers. And that's what happens when you play chicken with your work. This is the Yield Chair looking at the law, and for podcast, go to cbl5.com.
WBZ News Talk, just about...
I'm going to turn that down and let it cook a little bit. Typical of this trouble. As I said, it comes and goes. Right now it goes. It will come back, always does. For some reason, I guess part of it makes, there it is, starting to do it. This popping. Sometimes it takes a little while, I guess, for the, whatever the leakage paths are, to reestablish. It kind of makes sense in a way. They would come and go. It's not a particularly humid day here, which may or may not play a role with this trouble. So I am going to, rather than waste time, I'm going to let this play. And when it starts popping and wheezing, then I'll doing it a little bit, but not enough for a conclusive diagnosis by changing something. So I'm going to let it roll for a little while and see what happens. Oh, the problem will show, of course. When it does, we'll make a couple of cuts and see if we can nail down where it's coming from. I still think it's that one, but we'll see.